Today we're going to look at perimeter and area of triangles. To begin with, we're going to look at triangles using a grid. Now in the last video and in our last lesson with rectangles and squares, we realized that when they're on a grid, you really can just count. You could count around to find the perimeter, and you can count the number of squares inside to find the area. Well, when we go to do this for triangles, things get a little bit tricky. So let's look at one example. And we're going to look at the example that is up here, which is this triangle. So we're going to look at the green triangle in the right-hand corner. So when I go ahead and I try to count the perimeter, because remember, perimeter is just distance around. We know that one way to find perimeter is just to add up all the sides. And when I look here, I see that this triangle has a side length of 3 on the right-hand side, and it has a side length of 1, 2, 3, 4, 5 on the base. But when I get to this slanted piece, which is called our hypotenuse, it gets a little bit tricky. And so when we were investigating this, a lot of you were doing some different ways to try to figure it out. Some of you were finding how big one of the squares edges were right here, and then you were kind of estimating. And so we can kind of get an estimated answer. Again, I know that one side is 5 and I know another one is 3. That's not debatable. But when I get to the other one, I'm thinking it's about 5 or 6, so I'm going to go with 6. And so my estimate right now is that the perimeter of this is about 14. And again, I'm just going to call that units. Now when it comes to looking at the area, I run into sort of a similar situation, because normally I can count the square units inside. And so if I go ahead and try to count these, I notice that I have a full square, a full square, a full square, and a full square. So I know it's at least 4 square units. But the problem is that I don't fully know because I've got all these partials now. So when I look at this one, I see this is almost a full square, so it's about 5. And then I think, well, maybe this one and this one could go together. Oops, you can't see it. That one and that one could go together for another 6. And then maybe I have another 2. I'm estimating that the area is about 7. Okay, so I can definitely get an estimate, but I don't know if I can get an exact. Now the beauty of this is that when you have right triangles, which many of them, really all of them on here are, you really can almost get a better estimate. What gets really tricky is when you have a scalene triangle like the following. So I'm looking at the one that's down here in the left hand. In this case, it's not a right triangle. Well, it is a right triangle, but the way that it's situated on my grid is not giving me a lot of perfect side lengths or a lot of perfect squares inside. So it really gets tricky. So what we started to realize, and I'm going to move away from this one for now, delete that off, is that when we come back to the grid that we have, if we go back to our green triangle, that we started realizing that if we drew the other, if we kind of formed this into a square, what we ended up with was 2 congruent triangles. And therefore, we knew that if we knew the area of the rectangle, or the perimeter of the, or excuse me, just the area of the triangle, that, I'm totally messing this up. If we know the area of the rectangle, then the triangle would be half. And we started noticing that that was true for all of these right triangles, is that we could make them into squares or rectangles by just doing what you see me doing right now. Okay? So with that being said, if we could find out the base and we could find out the height, then we could start to create a general rule. And so this general rule becomes that A equals half base times height. Because remember, base times height is what we use when we talk about triangles, but base is sort of like another word for length and height is another word for width. It's just with triangles we talk base times height. So if we look at these rectangles, and again, I'm going to think about it as a rectangle now. If I take this one, for example, which is the one we were dealing with. Oh, my pen is not working. If I take this one over here, and I think A equals LW, and I see that the length is, looks like 6, and the width is 3, then my area is 18. Oops, and I'm noticing I made another mistake here, that my length is not 6, my length is 5. My width is 3, so I have an area of 15. And so now I know that if I know that, I can find half of it. And I know that half of 15 is 7.5. Okay, so that being said, remember I had predicted that the area was about 7, and I'm finding out now the exact answer is 7.5. So I do get a really good estimate when I count, but it gets really tricky and can get pretty cumbersome. So we have now arrived at our formula for area. So let's look at this. So now I'm giving you a triangle that is not on a grid anymore. It's just a triangle, and it has some dimensions on it. Now, you're going to see that there's 4 dimensions this time and not 3. And so we have to decide when we use each one. Now remember, I'm going to go from this from 2 perspectives. We're going to look at it for perimeter, and we're going to look at it for area. I know, again, that when I do perimeter, it's really distance around. So I'm really finding the sum of the sides. In this case, it's 3 sides. And for area, I now have a nice formula, which is A equals 1/2 BH. And so now I have to decide what goes where. Now remember, if perimeter is adding up the sides, you want to consider yourself, pretend you're standing at this part of my triangle, and it's like walking around the triangle. And so if you look at my path in red, it's really using these 3 numbers that are on the outside. So if I'm going to add them up, it's really going to be P equals 7 plus 9 plus 4, and then I can just add those nicely up, and I get 20, in this case, inches. Now when I get to area, things are a little bit different because now I'm dealing with base and I'm dealing with height. Okay? Remember, base can be any side that triangle sits on. And technically, I could turn this triangle and I can have it sit on any side, but right now it looks like it's currently sitting on this side where I see 9 inches. So in terms of the base, it's 9. Now when you get to the height, you've got to be careful. Because remember, the two dimensions we already used, the 4 and the 7, are not the height. That's just showing you if I were to walk up, let's say it was a mountain, that it would be a little bit steeper on the 4-inch side and it would be less steep on the 7-inch side. But in terms of the height is pretending that you're at the very tippy top of this mountain and you were to drop something, not roll it, but drop it, it would go straight down. And if you notice, the dimensions for going straight down is 6. So it's a 9 times 6, but remember I have to half it because 9 times 6 would be actually giving me the rectangle. If I was to make this triangle into a rectangle that you're seeing in blue, that would give me my 9 times 6, which is 54, but it's half of that. So therefore, it's half of, in this case, 54, and half of 54 is 27 inches squared. Okay, so there you have it. You finding both perimeter and area of a triangle. Again, you can do it on a grid, but it can get a little bit tricky. Using formulas is going to make it a little bit easier. Just make sure you're using the correct dimension.